In this video we solve mod of the binomial distribution. So here is the answer. To find the mod of binomial distribution, first we find variate of maximum frequency. As you know, when you calculate mod is the most repeated value. So your model class will be the class of maximum frequency, and then which is mostly represented by fm, and then you calculate frequency of class preceding the model class and frequency of class following the model class. Preceding consists of one term minus and following class, which is represented by fm plus 1 term add. So first maximum frequency calculate. Suppose that the greatest term in binomial distribution is q plus p whole power n is r. R is the maximum term, we suppose that. So one term minus, which is preceding class, probability of x is equal to r minus 1, less than or equal to probability of capital X is equal to r, which is the maximum frequency. So this is also greater than or equal to probability of x is equal to r plus 1, which is the frequency of the following class of model class. One term increase, here one term decrease. Now we put the formula of binomial distribution. The PDF of binomial distribution is NCX P of x q power n minus x. So NC r minus 1, p power r minus 1, q power n minus r plus 1. N minus the q is the difference of these two terms, n minus r minus minus plus 1. Similarly NCR p power r q power n minus r greater than or equal to NCR plus 1 p power r plus 1 q power the difference of these two terms, n minus r plus minus 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 1. So write this term by part. We can write it as p power r dot p power minus 1, because when base is same we add the powers. We can write it p r minus 1 or p r p minus 1. So these terms are equal. So similarly, write this term by part. We can write it as p r dot p. So divided by p r. When divide by p r, cut this term with this p r cut with this p r, and this p r cut with this p r. So we left with NCR minus 1, q power n minus r plus 1, p power minus 1, it is equal to 1 over p, less than or equal to NCR q power n minus r. NCR plus 1 p q power n minus r minus 1. So divided by q power n minus r. So write this term by part. Q n minus r q. When base are same we add these powers. We write it as n minus r plus 1, as we did in previous equation when solving PR. Here q n minus r minus 1, we can write it q n minus r q minus 1. Q power minus 1, write it as 1 over q. So divided q n minus r, cut these terms, and now we left with NC r minus 1 q over p, NC r minus 1 q over p. These terms are vanishes because these are cut with each other. NC r plus 1 p by q. Now we open the combination formula, which is, as you know, NCR is equal to n factorial over r factorial over n minus r factorial. So we expand combination formula here. N factorial r minus 1 factorial. The difference of these two terms factorial. N minus r minus plus 1 factorial. Q by p. Here n factorial r factorial n minus r factorial. N factorial r plus 1 factorial n minus r minus 1 factorial. So divided by n factorial. When you divide n factorial, here we remove the n factorial terms, we left with 1 over r minus 1 factorial n minus r plus 1 factorial q over p greater than equal to 1 over r factorial n minus r factorial greater than equal to 1 over r plus 1 factorial n minus r minus 1 factorial p by q. Now multiply this term by r factorial. So write r factorial in 3 equations. So when here is r factorial, cut this r factorial with this r factorial. So expand this. As you know, in factorial, when you expand factorial, it decrease by one point according to which as you need. Suppose that if you have 5 factorial, we open this 5 factorial with one term, we write it as 5 4 factorial, 5 minus 1 factorial, 5 minus 1 4 factorial. Similarly, if you have 6 factorial, you expand it one term, so you write 6 into 6 minus 1 factorial, 6 minus 1 5 factorial, so answer is 6 5 factorial. So using this formula, we write here r minus 1 factorial, and here r factorial r plus 1 minus 1 factorial, minus 1 plus 1 cut, and we left with r factorial n minus r minus 1 factorial. Again look this term r plus 1, we decrease it by one term. When you want to decrease, minus 1 plus 1 cut, we have r factorial. So cut this r factorial with this r factorial, and r minus 1 factorial with this r minus 1 factorial. So we have r over n minus r plus 1 factorial q by p, 1 over n minus r factorial, 1 over r plus 1 n minus r minus 1 factorial p by q. So multiply this term by n minus r factorial. R into n minus r factorial q by p n minus r factorial n minus r factorial. Cut this n minus r factorial, this n minus r factorial, we left with 1. And now we minimize r n minus r factorial, n minus r plus 1, decrease it by one term by using the factorial formula, n minus r plus 1 minus 1. This minus 1 and plus 1 cut, we left with n minus r factorial because we decreased this term by 1 minus 1. So cut this n minus r factorial with this n minus r factorial. We have here remaining r over n minus r plus 1 q over p greater than equal to 1. Here n minus r minus 1 factorial. We expand it one term, so decrease it by 1. N minus r, write n minus r as it is, n minus r minus 1 factorial over r plus 1 n minus r minus 1 factorial. Cut this with this n minus r factorial. So we have left here n minus r over r plus 1 p by q, 1 r over n minus r plus 1 q by p. So first we solve left hand side equation, which is rq over p n minus r plus 1 less than or equal to 1 by cross multiplication. Rq 1 into P into N minus R plus 1. NP minus RP plus P. This is equation 1. So now solving the right hand side. N minus R into P R plus 1Q less than equal to 1. N minus RP R plus 1Q. RQ plus Q. NP minus RP. This is equation 2. So from equation 1. This is equation 1. From equation 1. We solve equation 1. RQ less than equal to NP minus RP plus P. Take this term on right side. RQ plus RP less than equal to NP plus P. Taken P common. N plus 1. Taken R common here. Q plus P. Q plus P is equal to 1. R less than or equal to N plus 1P. From equation 2. NP minus RP less than RQ plus Q. Right R, this is error. RP is error, so I cut here, and this actually this is RQ. We look equation 2. NP minus RP less than RQ plus Q. So here is RQ. RQ plus Q. Cancel out this term. So NP minus Q. Take this Q on right side. This plus sign convert into minus. NP minus Q. And this term RP take on right side, and this minus changes into plus. So RQ plus RP. NP minus Q. Taken R common here because Q plus P is equal to 1. So we left with R. NP minus Q. So therefore NP minus Q. N plus 1P. Solving this, NP minus Q is equal to Q plus P is equal to 1. So Q is equal to 1 minus P. We write here 1 minus P. Minus 1 minus plus P. NP minus 1 plus P less than equal to R less than N plus 1 into P. Taking P common from both terms. P and P, taken P common. N plus 1 minus 1 R N plus 1 P. So the mode of distribution is an integer lying between N plus 1P and N plus 1P minus 1. So R is the integer. This lying between these terms N plus 1P and N plus 1P minus 1. So that implies that if mod is equal to NP, NP is the whole number. The greater term, that is mod, coincides with the mean of binomial distribution. So the greatest term, that is mod, coincides with the mean of the binomial distribution. If you like video, then click on like button and subscribe my channel Statisticians Club. You can find proof of all distributions of discrete and continuous families on my channel YouTube. I already solved discrete, uniform distribution, Bernoulli distribution and binomial distribution. Thanks for watching.